So dear conference participants, thanks for coming. My name is Vegard Skirbekk, and as Bill mentioned earlier, I head a group which is part of the World Population Program called the Asian Coach Change Project. We have two major focuses, one being on global productivity, the other one being on global beliefs, and we do both estimations and projections for both projects. Today I will give an example of our work within the productivity project, and the title is Demographic Change and Productive Potential Across the Globe. This figure shows the median age from 1980 to 2060 for various world regions. As you can see, the median age rises across most parts of the world, and the pace of the rise is, even if the Western countries, such as Western Europe or the US, has until now typically had a relatively high age. It was in the 1980s, these countries were in the 1980s overtaken by Japan, and also other parts of the world have a more rapid pace of aging than what has been seen in Western countries. This includes, for example, many parts of Asia, such as Indonesia or China. China will overtake the Nordic countries, for instance, in the 2020s in terms of its median age, according to the UN median variant population projections. And the question is, what does this imply for productivity? Does it mean that countries that have an older median age, are they going to face a larger problem to their productivity level than countries with a younger median age? Aging causes many challenges and can also cause huge costs, for example, to budgets, to fiscal sustainability. And one of the key policy responses for how to cope with aging is to increase the length of the working life. How long can we work when the populations are growing older? What determines our potential for retiring later? So we know that over recent decades, physical labor market demands have been falling continuously. Some evidence suggests that they've been decreasing for more than a century. And at the same time, cognitive abilities, mental performance, brain functioning has become increasingly important over time, both in terms of how long you can work, how well you can work, and for your health level. There's no health, but cognitive health was the conclusion of a recent World Health Organization publication. And cognitive abilities predict job performance increasingly better than any other observable pre-job characteristic. And the importance has been growing for a long period of time. Now, if you look at the traditional measures of aging, such as the old age dependency ratio, you typically look as you consider the dependent population, those who are age 65 and above, and the productive part of the population, those aged 15 to 64, which means that if you compare different countries, at different stages of the demographic transition, you find that countries that have an older age structure are likely to face larger productivity losses due to aging. However, as several researchers, including Warren Sanderson and Sergei Shabov and others, have pointed out in recent years, there must be other ways of considering aging rather than simply looking at an arbitrarily set age for when you get to become a burden. And the current paper, which I will present now, which is joint work with two of my IIASA colleagues, Elke Leuchinger and Daniela Weber, we use a very different definition of when people are old or when they become less productive. Rather than looking at the age when you are old, we look at the cognitive functional level. So since cognition has become increasingly important both for how long you can stay in the workforce and how long you can stay productive, how productive you are, and also for when you become dependent on the help from others. We use a definition of functional level based on the level of cognitive functioning. We use a standardized measure of, which I will define in a second, of short-term memory, where we consider not those who are 65 and above to be dependent, but those age 50 and above with low cognitive functioning. And for the productive part of the population, we consider those age 15 to 49 plus those age 50 and above with a high functional level. That is, you can still be aged 60 or 70 or even 90 and have a high functional level. It's not age dependent per se, it's dependent on your functional level. The test given, which by the way is the first objective test ever given to the majority of the world's population, it's a standardized memory test. It's always given in the local language. It's based on providing the respondents 10 very simple words, which are not supposed to be dependent on your prior knowledge. This can be, for example, grass, stone, corner, and the respondents will have 1 minute to recall these 10 very basic words. The proportion correct is used as a proxy for your cognitive performance. And what we find is that there is large variation, both with age. There is a clear age decline, which was well known in the literature, but we also find large variation between countries. You find that, for example, the US and Northern Europe performs relatively well. The proportion who remembers, who can recall, is relatively high, especially at younger ages, but it's also declining, while it differs strongly between nations. And for example, Mexico has a relatively low performance for this cognitive measure, and countries such as the continental European region fall somewhere in between. That is, there is huge variation across countries, which can say something more about how well people function at older ages rather than age distributions per se. And using this definition of your productivity, we find a very different ranking of aging. For example, if you compare this with the standard measure of old age dependency ratios, where if you find that India has the youngest population in the world with a proportion old age dependency ratio of 0.07, that is the proportion 65 plus over those aged 15 to 64, followed by Mexico, China, the US, and only then Northern Europe, continental and Southern Europe. So the India and Mexico would have the youngest demographic age structures in the world. But if you rather go to use the cognitively adjusted dependency ratio, you find a completely different rank ordering of countries. You find that the youngest country in the world is the United States, followed by Northern Europe, then only India and Mexico. Thereafter, continental Europe comes, China, and Southern Europe. So this implies that there's a completely different rank ordering of countries if you use an objective measure of how well people function rather than an arbitrary definition of old age. So what causes the differences across countries? Why do we see so large differences between the different world regions? Differences that are often very different than demographic age structures. Countries that are demographically young often tend to have relatively poor cognitive health and cognitive functioning. Education can be one important determinant of this. If you look at variation in education across countries, you find that for the 50-plus population, the United States has the highest education level, measured as the proportion with secondary education in the world. This is using data which my colleague Wolfgang Lutz have shown earlier, I believe, during the session 2 days ago. And we have a very similar rank ordering to what we have seen in terms of cognitive functioning. The better educated countries are also the countries that have the better cognitive performance. So the US is the best educated country, followed by the European countries, and the differences are large in terms of the proportions educated with secondary education. For example, Mexico, where you have a relatively low proportion with secondary education, and China, for example. So if you this education is not simply a matter of association, that countries which have anyway that there are factors that anyway both would raise education and cognitive performance. Education is likely to causally improve cognitive functioning. So longitudinal studies where you have higher levels of, you compare individuals with initially the same cognitive abilities, and you follow individuals over time, and you find that education actually is related to an increase in cognitive performance, net of initial ability. And also studies on monozygotic twins, where you can take care of some of the genetic factors that can also influence cognitive performance show that different educational outcomes is significantly affecting cognitive functioning. Further studies on neurological structures, such as a recent Swedish study by Johan Mortensen and colleagues, shows that neurological structures such as cortical thickness or hippocampus volume can actually change following intense educational training. And this can also lead to differences in performance by cohorts. This is an example of a Swedish study where we compare individuals born 1900 to 1925, shown by the solid line, and you find that the performance of this group in memory compared to those born 1926 to 1948 is very large. Those born 1926 to 1948, the later born group, has a cognitive performance which is so much higher that it is the same as if they were 16 years younger as the group born 1900 to 1925. There's been tremendous change across cohorts, and this change might be related to the fact that there is a much higher educational level and more investments in the more recent born cohorts. So to conclude, aging is inevitable. Demographic shifts there's no coming away from demographic shifts. You cannot avoid it through, for example, increases in fertility or immigration. The productivity variation is, however, more important than demographic variation in terms of determining the burden of aging. And stronger investments in cognition through, for instance, investments in education is likely to alleviate some of the negative consequences of aging. Thank you very much for your time, and I look forward to your comments later on.